mathematics class. This class is for class 8 and today we are starting a new chapter, that is triangles. That is we are following the textbook M.L. Agrawal, and that is chapter number 17 in your textbooks. Now this is a figure ABC. Generally, if I ask you all what is this, you will all say a triangle. What is the meaning of a triangle? In a layman's words, we can say a figure which is having three angles, 1, 2, 3. So it is known as a triangle. But what is the definition of triangle? What is a triangle? How you can explain it or how you can define it? What is a triangle? So triangle is a polygon. A polygon. Now what is a polygon? Polygon is a closed figure, closed by straight lines. Triangle is a polygon which has three sides and three angles. Triangle is a polygon with three sides and three angles. This is the smallest or shortest definition that can be talked about a triangle. So you can see and it is written as, suppose this is a triangle ABC. So I will draw a small triangle and I will write ABC. Now its sides are AB, BC and CA in cyclic order. So AB, BC and CA, and angles, first angle I'll take this, first, second, third. You can take any angle, you can start with anywhere, but I am taking first. So first angle is angle BAC, then angle ABC, then angle BCA. So it has three angles and three sides. A closed figure, a figure closed with three straight lines, which is having three sides and three angles, is known as a triangle. Now triangle is classified. Now we will move on to the classification of triangles. So triangles are classified on two bases, generally. What is that? Triangles are classified on the basis of sides and angles. Now on the basis of sides, there are three types of triangles. First is scalene triangle. Second is isosceles triangle. And third is equilateral triangle. Lateral means sides. The word lateral is its literal meaning is sides. Equilateral means equal and sides. So first of all, about scalene triangle, a triangle whose all the sides, the measure of all the sides is different. Let's say ABC. All the sides are different. The length of all the sides of a triangle are different. If the length of all the sides of a triangle are different, it is known as scalene triangle. Now, if in case two sides are equal, suppose I make x, y, z, in which I say x, y and x, z are equal. If two sides are equal, then and the third side is different. Third side is generally known as base in isosceles triangle, and it is different. If in a triangle two sides are same and third side is different, that is known as isosceles triangle. The different side is known as the base, and the base angles are equal. This is also one property of isosceles triangle, that angles opposite to equal sides are equal. So xz and xy are equal sides. Angle opposite to xz is angle y, and angle opposite to xy is angle z. So we can say angle y is equal to angle z. These are the properties of isosceles triangle. Then we move on to the equilateral triangle. Equilateral, just now we have discussed. is equal, and lateral means sides, means all the sides are equal, then it is known as equilateral triangle. PQR, I am taking a triangle PQR in which PQ is equal to QR is equal to RP. All the sides equal, so it is known as equilateral triangle. One more thing, all the angles of this triangle are equal and they are equal to 60 degrees. 60, 60, 60. How? Suppose these two sides are equal. If this is x, this angle will be x. Now these two sides are equal. If this is x, this is x also. So x, 3x is equal to 180. Sum of all the angles of the triangle is 180. So 3, 6, 18. So 60 degree. So each angle means angle P is equal to angle Q is equal to angle R. All the angles in equilateral triangle are equal and they are equal to 60 degree. Now this was a brief discussion about the types of triangles on the basis of sides. Now we move on to the type of triangles on the basis of their angles. So there are again three types of triangles based on their angles. First is you can say acute angled triangle. Second is obtuse angled triangle. Third is right angled triangle. Now acute angled triangle means all the angles are less than 90 degree. What is there in acute angle triangle? Suppose we talk about this triangle 1, 2, 3. This is also less than 90, 2 is also less than 90, 3 is also less than 90. So if in a triangle all its angles are less than 90 degree, it is known as acute angle triangle. Obtuse angle means one angle is greater than 90 and less than 180. So if I draw a triangle, let's say something like this. So this angle is greater than 90 degree. If this angle is greater than 90 degree or one angle is greater than 90 degree, it will be a acute angle triangle. That's why I have written, obtuse angle triangle. I have written obtuse angle triangle, one angle greater than 90 degree, because two angles cannot be greater than 90 degree, because if two angles are greater than 90 degree, then their sum will be more than 180, and we know that sum of all the angles of the triangle is 180 degree. So we won't find a third angle, so it will not make a triangle. Therefore only one angle has to be greater than 90 degree. In right angle triangle, again one angle is equal to 90 degree. Suppose I draw this type of triangle. In this, if I say this angle is 90 degree, so this will be known as right angle triangle. This was about a brief review of types of triangles on the basis of angles and sides. One more thing, in the right angle triangle, the side which is opposite to 90 degree is always known as hypotenuse. Side which is opposite to 90 degree. You can see this angle is 90 degree and side, let us say PQR. Angle Q is 90 degree and side opposite to angle Q is PR. So PR will be the hypotenuse. Now we move on to some more things that are related to the triangles, like median, altitude, and so many things. Now we will discuss different types of terms that are related to the triangle. So terms related to a triangle. First term is median. What is the meaning of a median? Suppose I draw a triangle. Let us say, name it as A, B, C. So a line joining a vertex and midpoint of the opposite side of the vertex. Suppose I take vertex A and let us say that this is the midpoint of BC, naming it as D. So AD will be known as median. This is the median of a triangle. What is the median of a triangle? If a line is drawn from the opposite vertex to the midpoint to the from a vertex to the midpoint of the opposite side, that line is known as median. So similarly, we will have three medians, and all the three medians lie inside the triangle. This BE is the median. At the same time, we can say that CF is the median. So all the medians lie inside the triangle. First point, medians inside. Medians lie inside the triangle. Inside of triangle. And one more thing, where all these medians meet, you can see they are meeting at a point, you can see this point. So a point where all the medians meet is known as centroid. Centroid is a point which is inside a triangle where all the three medians meet. Where all the three medians meet, this is known as. Next term is altitude. Now what is the meaning of altitude? The literal meaning of altitude is height, or to be more precise, it is known as perpendicular height. Now in a triangle, suppose this is a triangle, what is the altitude? A, B, C. If a perpendicular is drawn from a vertex to the opposite side, suppose I draw a line like this, and this is perpendicular, let us say N. So this will be termed as altitude. Now in this particular triangle, all the altitudes are inside the triangle. But sometimes altitude lies outside the triangle also. Suppose I make a triangle ABC. Now if I try to draw a perpendicular from point A, it means I have to extend CB, will be extended, and then this perpendicular will be drawn, let us say D. So AD will be the altitude of triangle ABC. You can see it is lying outside the triangle, means it is not necessary that all the altitudes lie inside the triangle. In this case, it is possible that yes, if you draw one more perpendicular and you draw one more perpendicular, all the triangle, all the altitudes or perpendiculars will be inside the triangle, but it is not necessary that all the perpendiculars or altitudes lie inside the triangle itself. In some cases, it stands outside also. And the meeting point, this point you can see, this is known as orthocenter. Orthocenter is a point where all the three perpendiculars meet. Let us say this point as M. So M is the orthocenter of the triangle ABC. And what is the orthocenter of a triangle? Where all the three perpendiculars meet, that is known as orthocenter of the triangle. Now next we come to the next topic is circumcenter and circumcircle. So suppose I take a triangle, something like this, and I draw its perpendicular bisector. We know how to draw the perpendicular bisector. Take the compass, let us say A, B, C. Open the compass more than half, cut an arc over here and cut an arc over here. From point B with the same measurement, cut an arc here and cut an arc here. So this line is perpendicular as well as it bisects AB into two equal parts. Let's say D. So here AD will be equal to DB. So this line is known as perpendicular bisector. Perpendicular bisector. Now a triangle has three sides. Now all the perpendicular bisectors, suppose of this point it will be something like this, and of this point it will be something like this. So this point where all the three perpendicular bisectors of the sides of a triangle meet is known as circumcenter. Circumcenter. Why? let us say this point as O, because we can say that OA will be equal to OB. Why? Because O lies on the perpendicular bisector of AB. Similarly, O lies on the perpendicular bisector of BC. This is BC, perpendicular bisector of BC. O lies on perpendicular bisector of BC. So OB will be equal to OC. From this you can say OA is equal to OB is equal to OC. OA is equal to OB is equal to OC. Means from center this A point, this C point and this B point is equal. So from center, if you take OA or OB or OC as radius, you will get a circle sort of thing. You will get a circle, though in my case it is not proper circle, but you will get a circle. That is why this O is what? The meeting point of all the perpendicular bisectors of the sides of a triangle. So this O is known as circumcenter, and this circle formed is known as circumcircle. So this is about circumcircle and circumcenter. Now we move on to incircle and incenter. Now what is incircle and incenter? So in the previous circumcircle and circumcenter, we bisected the sides of the triangle. Now here we are going to bisect the angles of the triangle. Now this is a bisector, let us say, and then this is the bisector, and then this is the bisector of a triangle. So this point is known as incenter. Why it is known as incenter? Because this distance and this distance as well as this distance are equal. So if we draw a circle, it will come something like this, and it will be formed inside the triangle. So this inside the triangle, that circle is formed, that is known as incircle, and the point of intersection of angle bisectors, where all the three angle bisectors of a triangle meet, is known as incenter. With the help of the incenter, we can take the radius and draw a circle that will lie inside the circle. So it is known as incircle, and this is the incenter. Now I hope we have discussed the main important properties of the triangles. Now if there is any theorem, we will discuss that, and then we'll move on to the exercise. Now the theorem that is used very much, that is prove that sum of three angles of a triangle is 180. What we do? We draw a triangle. Let us name it as ABC. Now this is a triangle ABC. We have to prove that angle A plus angle B plus angle C is equal to 180 degree. Means this angle plus this angle plus this angle. What we will do? We will make a construction. What is our construction? Construction is draw XY parallel to BC passing through A. From A, we will draw a line parallel to BC, something like this. Name it as XY. Now, since these two lines are parallel, whatever is the value of this, same will be value of this angle also, because that is alternate interior angle. If this is B, let us say this is angle 1, this is angle 2, and this is angle 3. So this angle 1 will be equal to this angle, means angle XAB is equal to angle ABC. Why? Because they are alternate interior angles. Similarly, this angle 3 will be equal to this angle 3, again because these two parallel lines are intersected by a transversal. So we can say angle YAC is equal to angle ACB. Again the reason is same, alternate interior angles. Now since XY is a straight line, so sum of all the angles means angle 1 plus angle 2 plus angle 3 will be 180, because this 1 angle plus 2 angle plus 3 angle is equal to they form a straight line, so we can say it is a straight angle. And same 1 plus 2 plus 3, these angles are in the triangle, so we can say angle A plus angle B plus angle C is equal to 180 degree. That is your proof. Proved. Now you are not supposed to learn this proof, but you need to remember that sum of all the three angles of a triangle is 180 degree. This is important to remember. One more theorem is there, that exterior angle of a triangle is equal to sum of opposite interior angles. I am just showing it. A, B, C, D. Exterior angle is ACD, and we have to prove that angle ACD is equal to angle CAB plus angle ABC, means this angle is equal to this angle plus this angle. So how we can say, we know that sum of all the interior angles of a triangle is 180 degree. Just now we have studied that sum of all the interior angles of a triangle is 180 degree. So we can say angle A plus angle B plus angle C is equal to 180 degree with the help of this previous sum of all the three angles of a triangle. So A plus B plus C is equal to 180 degree. Now we know that angle ACB plus angle ACD will be 180. We know that angle ACB plus angle ACD is equal to 180. Why? Because straight angle. BCD is a straight angle. This total angle is 180 degree, and that is a combination of ACB and ACD. So that is why sum of these two is equal to 180. This is equation number 1. This is equation number 2. If this total is equal to 180 and this total is equal to 180, so we can equate this and this. It means we can say angle A plus angle B plus angle C is equal to angle ACB plus angle ACD and ACB. But angle ACB is your angle C only. This angle and this angle can cancel each other. So angle A plus angle B is equal to ACD, and ACD is your exterior angle ACD. Now angle A can be written as BAC or CAB. So I am writing as angle CAB, and angle B can be written as ABC. So angle ABC is equal to exterior angle ACD. Now these were the things that were supposed to be known by you. You must know all these things before starting the exercise. So in the next class we will be starting up with the exercise that will be 17A. So till then, study hard, keep on watching, and stay blessed. Thank you.